Okay, so in this video we're going to talk about the other practicality of using integrals. I think probably the first video of this unit, I said the word indefinite integral, and I said that we're going to talk later about the difference between indefinite integral and definite integral. Well, an indefinite integral is what we've been doing this entire time. We've basically taken an equation and found what its integral was and put a plus c at the end because we don't know exactly where it falls. And then if we had another point, then we could then use that to find out what c was. But another use for an integral is actually to find the area underneath lines. So for example, in here, let's say this line right here is y equals x. Well, if we wanted to find what the area was from like here to, we want to find this shaded area underneath that line, and we'll stop at right here. We'll say this is x equals 3 or something. Then this area underneath here is actually found using integrals. And you would do the integral, and this is y equals x, we would say x dx, of course. And what you get for your answer is actually going to be a number instead of a line. And the reason we got getting lines before is because we were going from negative infinity to infinity, and for that reason you would just get a line in terms of x that would be all the slopes or whatever. But to represent, if we just wanted the area from 0 to 3, you put a 0 down here and a 3 up here. And what we have here is something called a definite integral, meaning that it's an integral that's defined from a certain x value to another certain x value. You're finding the area underneath it to the x-axis. I believe it's next unit, or maybe the unit after. I'm pretty sure it's next unit. We're going to be talking about how you could shift this around, and you could find the area of this even underneath here, and we'll be doing a lot of really not fun stuff like rotation and all this stuff, but it's like my least favorite unit. But basically, as of right now, it's to the x-axis. So you don't need to know calculus, though, to find the answer to this, because you know already that this is just going to make a triangle. That's a 45, 45, 90 triangle. But you don't even need to know that. You just need to know that it would be x equals 3, and because y equals x, if y equals and x was 3, then y also equals 3, and it would be 1/2 base times height. 1/2, 3, 3, which equals 9 over 2. And that wasn't calculus, that was geometry. I just said that because we know this line is y equals x, then we can just do that. And this means that this is 9 over 2. So that, and I only did that to teach you what a definite integral means. It means that this right here is the line in respect to that variable from 0 to 3. You don't need calculus to do this, though. Although the only reason you don't need calculus to do this is because this is an easy line that you know how to do already. And in the next video, I'm going to go ahead and mix things up and put a square root there, which is something you don't know how to do simply geometrically. And then we're going to talk about the first fundamental theory of calculus, but for right now, that's what that means, and that's just how I'm going to teach you the notation, basically.